This is our third example problem. And again, I'm using two different vectors, one given in polar form, one given as a slope form, in different quadrants, and just practicing entering these vectors into your calculator. So F1 is 10 kilonewtons. It's at 40 degrees from the negative y. And so to enter him in your calculator, this is 10 at minus 50. And so if you enter that in your calculator, you get 6.43 and then negative 7.66. 6.43 is 10 sine of 40, and negative 7.66 is 10 cosine 40. So if you're using a standard scientific calculator, this guy's given in a slope form. And this is not a perfect square. But if I take 5 and 6, so 5 squared is 25, 6 squared is 36, so 36 plus 25 is 61. So the hypotenuse here is the square root of 61. If I divide all three of these sides by the hypotenuse, I get 1, and this side is 5 over the square root of 61, and this side is 6 over the square root of 61. And so, or I can use the unit vector function of minus 6. So again, this is in third quadrant, and so the x component is minus 6, the y component is minus 5. So minus 6 minus 5, and that gives me this unit vector function here, or negative 6 over square root of 61, or negative 5 over square root of 61. So either way, once I get that unit vector from the slope, I multiply that times the magnitude, which is 12, and I get the actual F2 vector is negative 9.22 and negative 7.68. If I add this guy, F1, plus this guy, this guy, which is F2, plus this guy, which is F3, I get negative 2.79, negative 15.3 in Cartesian. And then I can convert that to polar on the calculator and get 15.6 at minus 100 degrees. If you draw the picture of this guy, so it's negative 2.79 and negative 15.3. So you know the vector is going to be in the third quadrant, just to the left of the negative y-axis. So that theta is the inverse tangent of 2.79 over 15.3. And so I get 10.3 degrees clockwise from the negative y direction. And so if you were going to write this in polar form, the magnitude is 15.55, but its direction is 90 plus 10.3, which is 100.3. And so finally, if you wrote that in polar form, it's 15.55 or 59 at minus 100.3 degrees, to put that into your calculator. So again, these are problems I like, just different vectors given in polar form, slope form, different quadrants, and you just need to know how to enter the vector and how to deal with the slope and how to get the proper unit vector with the correct signs as the components here. So this is example problem 3.